Okay. So we have to see some basic definitions related to this coordination chemistry. Okay, so first thing is nothing but said to be the coordinate bond. Okay, so we already talked over this concept, that is what say the coordinate bond. Coordinate bond is also said to be the dative bond or the covalent bond. Okay, so see here, this picture it shows say the formation of the coordinate bond. So this is nothing but said to be the nitrogen. Okay, it's an Lewis structure of say the ammonia. Nitrogen is having what, three hydrogen atoms. Along with that, they contain what, one lone pair. So this is what say the lone pair. Okay. So due to the presence of this lone pair, so this lone pair is free for what say the donation to any electrophilic species towards, okay, towards any electrophilic species. That's why due to the presence of this lone pair, that ammonia is basic, okay, basic in nature. Okay, and we can say that it is a Lewis base. Okay, so it's a Lewis base. So what happens when such type of molecule, that is what say the ammonia, comes in contact with the electron deficient, such as what say this proton. Okay, so that is what say the H positive. So what happens, this lone pair will going to attack over this proton. Okay, and there is a bond formation in between the nitrogen and the hydrogen atom. Okay, like that. This one is nothing but said to be the this one, this bond. Okay, this bond, this one. So that bond, this arrow can be shown, say the new bond form in between the nitrogen and this hydrogen atom. Okay, so they see the direction of the bond is towards what say the hydrogen, because what say the electron density from nitrogen is say moving towards what say the hydrogen, and there is a say the covalent bond formation in between the nitrogen and hydrogen. So why it is called as what say the coordinate bond? Okay, it is a covalent bond, or sometimes it is called as the covalent coordinate bond. So why it is called as the covalent bond, I will tell you, because what say we have what, two electrons in this bond, okay, that will go to share in between what say the nitrogen and hydrogen. That's why it is said to be the covalent bond. Why it is called as the coordinate bond? See, because whatever the two electrons required for the bond formation in between the nitrogen and hydrogens, both electrons are coming from what's in the nitrogen, because hydrogens, they don't have electron. Both electrons required for the bond formation in between the hydrogen and nitrogen are coming from what, nitrogen. Okay, so that's why this bond is said to be the coordinate bond, because nitrogen will going to coordinate this hydrogen by giving their own electrons to them. So that's why this bond is nothing but the coordinate bond. And always coordinate bond can be shown by means of what, such type of arrow. Okay, and the direction of the arrow, it indicate the you can say that the moving of electron density from one element to the one atom to the other atom. Means here the electron density present over nitrogen atom is moving towards what's the hydrogen. So that's why we have to write down such type of arrow over here. So this is all about what say the bond formation in between the hydrogen and nitrogen. Okay, so I thought you understand about what's the coordinate bond. So what is coordinate bond? Coordinate bond is nothing but the covalent bond formed in between the two you can say that the atoms. Okay, but whatever the electrons required for the formation of this bond, that electron is provided by only one atom. Here example is what say the nitrogen. So those nitrogen can provide both electron to what say the hydrogen atom. Okay, so this is all about what say the coordinate bond. This definition may be asked in say the examination for 1 marks. Another is nothing but said to be the ligand. Okay, so see, I already told you we have say coordinate bond. So in which thing we have say the coordinate bond. So we have two entities. I already told you. The first one is what say the Lewis acid. So what is Lewis acid? Lewis acid is nothing but said to be the metals which provide the empty orbitals. Okay, which provide what say the empty orbitals in which the ligand. Okay, so ligand is nothing but three types of species, that is what, positive, negative and neutral. Okay, so three types of species you can say that the ligand, they are able to donate the electron to the metal. Okay, so actually the coordinate bond form in between what's the ligand and metal. Okay, so metal is having empty orbital, ligand is having the filled orbital. So the electrons, they can flow from what's the ligand to the metal. Okay, so that's why the ligand is nothing but the Lewis base, and metal is nothing but said to be the Lewis acid. So here we write what ligand is an ion or a molecule, okay, or a functional group that bind a central metal atom. Okay, so I already told you what is central metal ion or atom. The metal is said to be the central metal ion if it is present in the positive state. So it is called as what's the ion, CMI, CMI, central metal ion. Okay, if it is present in the zero oxidation state, so we can call as what, CMA, that is what, central metal atom, central metal atom. Okay, so this picture is show the so the concept regarding this is what say the receptor, this one is what say the receptor. What receptor? So this is what say the metal which having what say the empty orbital, so this is what say the empty orbital, and this one is what say the ligand which having what say the electron pair. Okay, we have the electron pair, so that electron pair will going to fit up into the vacant orbitals of the metal, and that's why there is a formation of the covalent bond in between what say the night, you can say that the metal and the ligand. So here in this diagram, this is what say the electron density, okay, of ligand, and they are fit into what say the vacant orbital of the metal, and due to that there is a formation of the covalent bond. Okay, you can say that the coordinate bond in between what say the ligand and the metal. So we have what say three types of ligand. I have already told you, that is positive, negative, and neutral ligand. Okay, so now we talk about say the next topic. Yeah, so we have to classify the ligands. Okay, actually, so we have what are so many types of ligands depending upon what's their charges. So generally we are going to do the classification of ligand depending upon their say charges. Okay, means whether they have what say the positive charge, whether they have what say the negative charge, or they may have say the neutral. So here we are going to categorize some ligands into what's the negative, positive, and neutral ligand. So here in this case we have what say the negative ligand. So we have what cyanide is there, Cn, then NO2 negative, that is nitrite. Okay, here hydroxide is there. Okay, and then nitrate is there, fluoride, chloride, bromide, and oxide is there. So these are nothing but the ligands which have what say the negative charge. Okay, they have negative charge, so that's why they are called as what's the negative ions or the negative ligands. We have some examples of the positive ligand such as what's the positive, nitro nitrocilium. Okay, and another is nothing but said to be the hydrazinium. Okay, so it is nothing but said to be the positive part of the hydrazine. Okay, and some neutral ligands we also have. So first one is what say the CO, which is also called as the carbonyl. Okay, carbonyl or carbon monoxide is there. Another is what say the ammonia. Okay, ammonia, which is very basic ligand used in the formation of the coordination compound. Then another is what water. The next is what ammonium hydroxide, hydroxyl amine is there. Then next one is what's the methylamine. So these are nothing but just few ligand, or a list of the few ligands which are categorized into the negative, positive, and neutral ligands. You have to rememberize that ligands. I think in your book we have say we have you can say that list of this ligand. Okay, so okay, so we have a list of this ligand, so you go through this. Okay, and you by heard this miss which type of ligand is this. So either negative, positive, or neutral. So just by observing this you get the idea about this. Whenever we have what say the negative, so it is a negative ligand. Whenever we have say the positive, so very few positive, either two positive ligands we have in our syllabus. And then finally we have what say the neutral molecules. Okay, so we further move towards what this one. Okay, so that is nothing but say Types of say the ligands, say the classifications on the classification based on say the, you can say that the coordination number. Okay, so what is coordination number? I will tell you. Okay, so see here, when what say we're going to form a coordination compound, okay, coordination complex or coordination compound. So the coordination compounds, they may have what say the one ligand, two ligand, more than one. Okay, means they either they have what say the two ligand, three ligand, four, five, six, seven, eight, like that. Okay, so whatever the number of ligands attached to the metal, so that number is nothing but the coordination number of that metal. Okay, it means that suppose we have we considered what is the basic examples in our first slides, that is nothing but with the hexamine nickel, hexamine nickel 2. Okay, so here 6 NH3 is surrounded by means of what's the nickel, and that's why the coordination number of the nickel is nothing but said to be 6. Okay, so have you got any idea about coordination number? Whatever the number of ligands surrounded by the metal, that number is nothing but the coordination number of that metal. Number of ligands attached to the metal, that number is called as what's the coordination number. Okay, so see what we have, what types of ligands. So here is monodentate, bidentate, tridentate, tetra and hexadentate. Okay, so we talk about what do you mean by monodentate, bidentate and tridentate. Okay, so see, we have such type of ligands, okay, who is capable to donate only one lone pair. Okay, is those ligands which is capable to donate only one lone pair. So that ligand is nothing but said to be the monodentate ligand. Okay. Conversely, suppose the ligand is having capacity to donate two lone pair. For example, the H2 and NH3, they are capable to donate only one lone pair. That's why they are classified into the monodentate ligand. Okay, and water and what's the ammonia. Their abbreviation is nothing but ACO and amine. Okay, here is what examples of the biodentate ligand. So what is bio? Bio means what? Bio means two. Okay, so here we have what some examples. Okay, where they can donate what two lone pair. So it is what ethylene diamine. Okay, ethylene diamine. So here we have what two NH2 groups. So they have capacity to donate two electron pair, two lone pair. So that's why it is an biodentate ligand. Similarly, this one, it is an oxalate, oxalato. Okay, oxalato is there. Okay, oxalato. We have to rememberize this name. Aco, amine, ion, oxo. Okay, this one. Then third is nothing but said to be the dimethyl glycine. Okay, so having know that these compounds we use for say the detection of the nickel. Okay, so when we have a solution of the nickel and we can add what's the alcoholic solution of the DMG into it, we got a, I can say that the red color PPT we got. Okay, so this is what's the DMG, dimethyl glycine. So it is also have what's the biodentate ligand. Okay. So this is what's the biodentate. So have you clear about what monodentate and biodentate? Monodentate means what? Those who donate only one lone pair. That is what monodentate. Biodentate means what? Those ligands have capability to donate the two electron pairs. They are called as what's the biodentate. So obviously we have a tridentate is there. Means diethylene triamine. Okay, diethylene. So this is what diethylene. Okay, and triamine. 1, 2, 3 nitrogens we have. Okay, so it is what diethylene triamine. So they have capability to donate the two electron pairs. Okay, so that's why it is a tridentate ligand. Okay, then we have a tetradentate, like what triethylene tetramine. So we have a triethylene 1, 2, and 3. Triethylene and tetramine. We have what four nitrogen atoms. So they have a capacity to donate the four electrons pair. That's why it is called the tetradentate ligand. And next one is nothing but the hexadentate, which in the best example is what EDTA. So EDTA has capacity to donate say the 6 electron pair. Okay, 6 electrons pair. So this is nothing but 2 by means of what's the nitrogen and another 4 by means of what's the oxygen. So total 6 electrons pair donated to the metal ion, means they can form a 6 bond. Okay, one molecule can form a six bonds, so that's what is called as what, hexadentate ligand. Okay, hexadentate. So here we have an idea related to this monodentate to the hexadentate. Means monodentate means those ligand having ability to form only one bond. Those who form two bonds, that is called as bidentate. Those who form three bonds, they are called as a tridentate. Those who form what say the four bonds, they are called as a tetra, and similarly with what say the hexadentate ligand. Yeah. So these are nothing but said to be some you can say that say coordination number of metals. Okay, so we have to learn about what this one. Okay, we have to, you can say that remind about what this one. Okay, so here we have a list of what's the metal ions. So this is nothing but said to be the list of what's the metal ion. That is what the Ag positive, then what Pb positive, Cu, Zn, Hg, Co, that is cobalt. Okay, Fe, then here. So here the same metal will be present in the different oxidation state. Okay, and when they say reacted with what's the ligand, so they can form what the variety of complex here. Okay, so I will explain what do you mean by the coordination number. Okay, so here see what this is what the Eg which is present in the positive state, when it is react with what's the NH3, so only two molecules of NH3 will engage over here. We got what here the name of this complex is nothing but diamine argentate. Okay, so I will tell you the name of particular metal. Means we have to write down in the other language. Okay, so this is an what complex. So here this Eg is binded towards say only two NH3. Okay, so that's why the coordination number of the Eg is nothing but said to be the 2. Okay, conversely when we talk about what this one, so here is nothing but zinc which is present in the dipositive state, reacts with what's the four you can say that Cn, that is what cyanide. Okay, cyno. So here what tetracyno zinc. Okay, tetracyno zinc. So here what this zinc is attached towards say the 4 cyanide. So that's why the coordination number of zinc is nothing but said to be the 4. Conversely, when we talk about what the Ep positive, it can react with what is the 6 echo complex or a 6 echo molecule. That is what H2 molecule. We got what this hexa echo. You can say that iron 2. Okay, hexa echo iron 2. So we got what such type of complex. Okay, and here we have what a 6 echo molecules are attached towards say the one Fe. That's why the coordination number of this one is nothing but said to be the 6. Okay, so this is all about what's the coordination number. Yeah. So next definition is nothing but said to be the chelate. Okay, so this one is the most important definition, can be asked in the examination. Chelate is nothing but said to be the cyclic. So we already know that we have what so many types of ligand. Okay, monodentate, bidentate, tridentate, tetradentate, and hexadentate. Okay, so we have a such type of ligand who form a ring with what's the metal. So I already told over here. Okay, so here we have what say this metal, and when this nitrogen can attach towards the metal by means of the coordinate bond, so they can form a ring. So this one is nothing but said to be the ring. Okay, so this ring compound or this ring complex is nothing but called as what's the chelate. Okay, so we have what's the definition: this cyclic compound containing the polydentate ligand and the metal. Okay, means what? Say when the polydentate ligand is bonded, coordinately bonded to the central metal ion, and when they form a cyclic compound, so that cyclic compound is called as what's the chelate. They're called as what's the just like a crab. Crab. So we have what? Whenever suppose whatever the objects in their okay, say mouth. Okay, so we can say that what this is an uh, this is what just like a cyclic compound. Okay, so whenever we have what say the polydentate ligand attached towards say the central metal ion, so we got what say the cycle, and that molecule is nothing but called as what say the chelate. Okay, so whenever you listen this chelate, so the chelate is nothing but said to be the cyclic coordination complexes. Cyclic coordination complexes are nothing but said to be the chelate. And this next in this process the metal ion combine with what's the polydentate ligand to form a ring. So I already told you this is nothing but say the structure where what's the Ep positive is this is an porphyrin ring. Okay, So this porphyrin ring can form an interaction with what's the Fe, and we got what's a such type of ring. So that's why this complex is nothing but called as what? It is a coordination complex, but it is called as what's the chelate. So chelate is nothing but the coordination complex, but coordination complex are of what two types. So either they are acyclic or cyclic. So when they are cyclic, so they are called as what's the chelate. Okay. Okay. So we stop over here.